Okay, last time we graphed, we went ahead and we graphed in what we called standard form. So standard form is our regular quadratic equation, y equals ax squared plus bx plus c. But we do have a specialty form, and it's my favorite because it makes it so easy to graph. And that specialty form is called vertex form. And it's called vertex form because they pretty much tell you where your vertex is. It gives you your a so you can find your slope. So there's really not a lot of calculation involved. So here's your a for your slope. And then your vertex is what we call hk. So because we have an h and a k here, those are our vertex. But keep in mind, this is a negative h, which means that the number in here is really the opposite sign of our true x value of our vertex. So as we go through, we always change the sign of what's inside the parentheses, but we leave this one the same. And we did that too when we graphed in point slope form. Back in chapter 4, we did transformational form. And transformational form of a line looked just like this. So we're trying to relate that back to what we did. So we're going to go ahead and look at our first problem. Our a value is 2, so that's going to deal with our pattern of change. So our pattern will be 2 times 1, 2 times 3, 2 times 5, and that'll be our slope. And then our vertex will be the opposite sign of this, so negative 5, and the same size as that sign as that, negative 7. So now all we have to do is graph that vertex that we got from our vertex form, which we love. So we go negative 5, negative 7. There's our vertex, and now we use our pattern up 2 over 1, up 6 over 1, and then we would go up 10 over 1, but we kind of run out of room. But it gives us a good idea of what our graph looks like. So we'll try the next one. This time our a is negative 1. So now our slope or our pattern will be negative 1, negative 3, negative 5, negative 7. And then our vertex will be opposite sign, so positive 7, positive 9. So I go to 7, 9. And now our slope is down 1 over 1, down 3, 1, 2, 3 over 1, down 5 over 1, down 7 over 1. And it's your responsibility to make sure that as long as you have room for those dots on there, you put those dots on there to make sure your graph is accurate. Because remember, a graph is really a visual representation of all possible answers to the equation. All points, x, y, that would work in that equation. So our graph needs to be accurate. So the next one, we're going to go ahead. This time our a is 1/2. Ooh, a tricky one. Kind of threw it in there because what happens when we have a fraction, our vertex will be negative 1 and positive 4. So we'll go to negative 1, positive 4. And now our slope should be 1/2 times 1, 1/2 times 3, 1/2 times 5. What's weird though is that when you have a slope of 1/2, you don't go up 1 over 2. You go up 1/2 over 1. So from here I go up 1/2 and over 1. And then this is over 1.5, up 1.5 over 1. So up 1.5 over 1. 1.5 over 1. And then up 2.5 over 1. So 2.5 over 1. And so the fractions really aren't all that fun, but they're manageable for the most part. Okay, next one. Our a is 1. So we're still going to have that pattern 1, 3, 5, 7. Our vertex is negative 9 and 0. So negative 9 and 0. And then we go up 1 over 1, up 3, 1, 2, 3 over 1, up 5 over 1, and now we have our graph. Okay, one more set of examples, and this one's weird because there's no parentheses. So this is really the same thing as there's no number inside the parentheses, which means that if you just have an x squared, that x value is going to be 0 for our vertex. And then over here, that's our y value for vertex. So we're starting at 0, 3. And then since there's a 1 in front, we're going to have that pattern of 1, 3, 5, 7. So up 1 over 1, up 3, 1, 2, 3 over 1. And there's our graph. So on our next problem, again, there's no parentheses, which means that we have no x value of our vertex, but we do have a y value of our vertex. So we're going to be at 0, negative 5. And then our a is 2. So 1 times 2, 3 times 2, 5 times 2. And then we go ahead and graph. So up 2 over 1, both directions. Up 6, 1, 2, 3, 4, 5, 6 over 1. And then up 10, which we run out of room. And there's our graph. So that's it so far. We've graphed in standard form, we've graphed in vertex form, and then what we're going to do now is we're going to talk about the transformations. So we're going back to that vocabulary we used in chapter 4, like a vertical shift, a horizontal shift, a vertical stretch, a vertical compression.